Okay, get this. What if a liquid could just defy gravity? Like climb right out of its own container? It sounds like something straight out of a sci-fi movie, but today we are diving into one of the absolute strangest, most paradoxical states of matter in the entire universe, the superfluid. Just try to wrap your head around this. A fluid so perfect, so completely and utterly frictionless, that once you get it moving, it just never stops. A liquid that can pull off tricks that seem to break the very laws of physics as we know them.
And I'm not kidding, this is a real thing. When you take certain materials, like helium-4, and you cool them down to temperatures just a hair above absolute zero, we're talking the coldest anything can possibly get, they pop into this bizarre state. And the first thing you notice? It absolutely refuses to be contained.
What happens is, a super thin, totally invisible layer called the Rowland film forms on literally every surface it can touch. This film acts like a tiny microscopic siphon, letting the liquid creep up the inside of a bowl, over the edge, and down the other side. It looks for all the world like it's ignoring gravity.
And it does not stop. This process just keeps on going relentlessly until the liquid finds its own level, even if that means it has to completely empty its own container, drop by drop, until there's absolutely nothing left inside. Wild, right?
So, how on earth does a liquid just decide to climb out of its own bowl? I mean, what's going on here? To figure this out, we've got to shrink way, way down and take a look at the world of quantum mechanics.
It all boils down to one single property. A property that seems simple, but completely bends reality. A total and complete lack of friction.
Okay, so the secret sauce to all these seemingly magical powers is its total lack of friction. In physics, we call a fluid's internal friction viscosity. You know, it's what makes honey all thick and slow while water is thin and runny. Well, a superfluid has zero viscosity, and with nothing to slow it down, it can just keep on flowing, pretty much forever.
This comparison right here really drives home just how weird this is. I mean, look, on the left, you've got any liquid you've ever seen. It has viscosity, that friction, right? So it loses energy, it slows down, it stops. But on the right, you've got a superfluid. It's perfectly frictionless. It holds onto its kinetic energy, which lets it flow, in theory, for all time.
So why does this happen? Well, it's because of a fundamental difference between particles. You can think of helium-4 atoms as what are called bosons. They're like the social butterflies of the particle world. They're happy to all pile into the exact same quantum state. So at these super low temperatures, they all link up and start acting like one giant superatom. Now, helium-3 atoms are fermions. They're a bit more individualistic, so they have to pair up first before they can join the party and achieve this collective state.
And you know, this bizarre behavior isn't just some weird quirk of liquid helium. Nope. In labs all over the world, physicists are now actually forging these exotic states of matter on demand. They are pushing the absolute boundaries of what we thought was possible.
This timeline really shows you how far we've come. I mean, after that initial discovery way back in '37, it took decades. But by the late 90s, researchers were creating superfluids out of atomic gases. And that led to some incredible breakthroughs, like seeing quantum vortices with their own eyes, and, in 2005, finally creating a superfluid from a fermionic gas.
Seriously, one of the most mind-blowing applications of all this research came from a physicist named Lin Hao. In 1999, she used a type of superfluid called a Bose-Einstein condensate to slow a beam of light down from its universal speed limit to just 17 meters per second. That's about the speed of a bicycle. And later, she brought it to a complete stop. She stopped light.
And listen to this quote. It just perfectly illustrates the bizarre forces at play. Howe's team even created superfluid shockwaves and little tornadoes, and they saw what she called phantom propellers made out of these vortex rings. It's like having a direct window into watching superfluidity break down at the quantum level. So all of this incredible work in the lab, it really makes you wonder, right? Is this strange, frictionless state of matter just something we can cook up here on Earth? Or does it exist naturally somewhere else out there in the universe?
Well, it turns out the answer might be hiding in the hearts of some of the most extreme, most violent objects that we know exist anywhere in the cosmos.
Physicists have a theory that the matter deep inside neutron stars, these incredibly dense leftovers from massive stars that have exploded, actually behaves like one gigantic superfluid. The insane pressure, and believe it or not, relatively low temperatures in there, are the perfect conditions for the protons and neutrons to form special Cooper pairs, creating a massive, frictionless sea of particles right in the star's core.
All right, let's take this idea to its ultimate logical conclusion. Because some physicists have proposed a truly mind-bending theory about the fundamental nature of reality itself. Brace yourself for this one.
It's called the superfluid vacuum theory, and it suggests that the empty space all around us, the very fabric of space-time, isn't empty at all. Nope. It's actually a kind of cosmic superfluid, and everything we see, all matter and energy, is just a ripple or an excitation moving through it.
Now, the grand ambition here, the ultimate goal, is to finally unite the two pillars of modern physics, quantum mechanics and Einstein's theory of gravity. If this superfluid vacuum theory is correct, it could be a theory of everything, explaining all the fundamental forces and particles as just different ripples in this one single underlying superfluid vacuum.
So let me just leave you with this provocative final thought. What if the universe isn't a collection of tiny particles just moving through empty space? What if the universe is a single, giant, frictionless quantum fluid? And what if you, me, and everything we've ever known are just disturbances in that fluid? It's a truly strange idea that all started with a simple, impossible liquid deciding to climb out of a bowl.